All right, so here we go. Today we're going to start with 3.3. 3.3 is proving lines parallel. Proving lines parallel. Proving lines parallel. Okay, all right. So let's go ahead and start with a postulate on page 162. On page 162. All right. Postulate 3-3-1. The converse of the corresponding angles postulate. If two coplanar lines are cut by a transversal so that a pair of corresponding angles are congruent, then the two lines are parallel. Okay, so this is the converse of what we already talked about, right? Because we already know that in the if I have, say previously we learned that if I had two parallel lines and I cut it with a transversal line and the corresponding angles are the same. Okay, no. So if I have two parallel lines, I cut it by a transversal, then the corresponding angles are the same, congruent, right? So if, in other words, if parallel, then the corresponding angles are congruent, right? Okay. Now we're going to do the converse. So what they're saying is that if the two corresponding angles are congruent, then the two lines are now going to be parallel. So it's the converse of what we already know, right? Okay. And if it works both ways, what are these called? Does anybody remember that? I know it's been like, huh? I heard it.
Biconditional.
Biconditional, right? So this is biconditional statement, right? Because it works both ways, right? So in other words, again, so the converse is that we're saying that if I have two lines, all right, and I cut them and the corresponding angles are congruent, then they are parallel, okay? All right, so that's what that is. Let's go to example number 1. Using the converse of the corresponding angle postulate. Use the converse of the postulate and the given information to show that the two lines L and M are parallel. So they're telling us that I have two lines and I cut them with a transversal. And I have 1, 2, 3, 4, 5, 6, 7, 8. And they're saying if I cut those two lines with a transversal and 1 and 5 are congruent, so 1 and 5 are congruent, okay? If these two are congruent, okay, by the converse of the corresponding angle postulate, I know that these two lines have to be parallel, right? Okay. In B, it says that angle 4, value of angle 4 is equal to 2x plus 10, and the angle 8 is equal to 3x minus 55. Okay. And they're giving us x as 65, and x is 65, okay? Now I have to prove that these two are congruent, these two are parallel. And the way I do that is that if I put m into m4, 2 times 65 is 130 plus 10 is 140. So angle 4 is 140. Angle 8 is 3x. So it's a 3 times 65, which would be 195. Minus 55 is going to be, again, 140. So angle 4 and angle 8, which just happen to be corresponding angles, are congruent. So since the corresponding angles are congruent, I can say that these two lines are parallel using the converse of the corresponding angle postulate. Okay. Okay, let's go up to page 163. on page 163 on the top, there is a parallel postulate. Through a point P not on line L, there is exactly one line parallel to line L. So if I have a line L, if I have a line like this and I have a point P, okay, of all the parallel lines associated with this line L that I can draw, right? There are many parallel lines across this, I get to this line L. There's only one that goes through line P, right? In other words, we call this, we're anchoring the parallel line to point P, okay? More interestingly, there is a construction, and it says, gives you an idea how to draw a parallel line. So how would I actually draw this parallel line using, let's say if I had a, what are those things called? The if I drew a line like this, okay, with, I'm gonna move this out a little bit over here, so it's easier for us to draw, okay? I'm gonna take a, what are the thing that looks like this, that opens up like this, what are these called? Anybody? Nobody knows what this is called? Where you have the pointy things, and it goes like this? Nobody knows this? All right, look that up, find that out, because I'm forgetting it too. Okay,
Like
we'll call
a protractor?
a protractor. There you go. Well, no. A protractor is where you measure it measure the angle with, right?
Yeah. Oh, so like the thing where you put the point on and then use the pencil part to draw
Yes,
something?
exactly.
Oh,
That's what I'm talking about.
A compass.
A compass. There you go. A compass. So who was that?
Me, Holden.
Holden. Good job, Holden. Extra point for Holden. So here we go. So I would anchor this here and I would go like that, right? Okay. So to do this, what are we doing here? What does it say? We're going to go ahead and, okay, let's move this P over here. So how am I going to draw a line over here that's parallel to this line? What I'm going to do is I'm going to take my protractor. Actually, let's go ahead and see if I can actually do this using the red one. So I'm going to take my protractor and go like this. And then I'm going to take that same angle without moving it. I'm going to go like this, right? So what I have here is I've created this guy and this guy are the same, right? Then I'm going to go ahead and, well, actually, I'm going to go ahead and I'm going to move this all the way through up to here, right? Up to here like this. Okay. So I have this angle, this guy, and this guy are the same because they're the same distance, right? Because I didn't change it, right? Okay. Then I'm going to go ahead and measure like this. Okay. I'm going to use it again, and I'm going to go like this. I'm going to get that. I'm going to take that same one, and I'm going to go like that. Okay. So over here, okay, let's start from the beginning. So I went like this, right? I went like this, went at the beginning. I went like that. I'm going to take that same one. I'm going to go like that. Okay. So this guy, and this guy, and this guy, these three, this line, and this line are all the same. Now I'm going to go ahead and take this, measure this, and go like that, and measure this, and go like that. So I'm going to measure it like that, which means that now this line and this distance are the same. Okay, now I'm going to take this point, and I'm going to go ahead and connect it, and there's my parallel line. This guy here and this guy here are parallel, okay? Or actually the better way to notate that would be like this, right? So this line here and this line here would be parallel, okay? All right. Let's go ahead and go down to page 163. On the bottom of page 163, there is proving lines parallel. I want each of you to read these on your own. There are 3 of them, and they should read exactly like the postulate that we just read, okay? They are the converse of things you already know. So I'll give you some time to read that. Are there any questions on that? Are there any questions on that? As you can see, they are all converse of things that we already know, right? Converse of the alternate interior, converse of the alternate exterior, and converse of the same side corresponding, same side interior angles, right? Okay, let's go on to go to page 164. Example number 2, determining whether lines are parallel. Using the given information and the theorems that you have learned to show that R and S are parallel. So I have R and I have S here, trying to prove that these two lines are parallel. The first one is that they're going to say that 2 and 6 are congruent. Angle 2 and angle 6 are congruent. If angle 2 and angle 6 are congruent, and you're considering these two lines, okay, what is 2 and 6? What kind of angles are they? Kayla? Kayla?
They are
2 and 6. They're inside, they're interior, right? Because they're inside the line. They're what?
interior angles.
Yeah, so they're alternate interior angles, right? Because they're not on the same side, right? So they're alternate interior angles. So by the converse of the alternate interior angles, since they are congruent, these two lines must be parallel, would be your argument, right? That's how you'd prove that. And the second one says that angle 6, oops. Angle 6 is 6x plus 18. Angle 7 is 9x plus 12, 9x plus 12. Okay, let's look at 6 and 7 first. 6 and 7, what kind of angles are these?
Same side interior angles.
They are same side interior angles. Again, they're interior and they're on the same side. They're on the same side of the transversal, right? So if these two are, what do these two have to be to make this parallel? The same side interior angles are going to be what? If they are parallel, they are going to be supplementary, right? They have to add to 180. So let's see if that happens. X is equal to 10. They're telling us that X is equal to 10. So angle 6 is going to be 60 plus 18, which will be 78. Angle 7 is going to be 90 plus 12, which is 102. Lo and behold, if you add these two together, you're going to get 180, which means that the same side interior angles are supplementary, so that these two must be parallel. Okay? All right, so that's how that works. Let's see if we can do example number 3. Example number 3, proving lines are parallel. Given that L and M are parallel and angle 1 and angle 3 are congruent, prove that R and P are parallel. So we have LM, L, and M. We have been told that this is parallel. And then we have P and R. We have P and R, and we are told we are given a 1, 2, and 3. And we are given that 1 and 3 are congruent. So we're given that 1 and 3 are congruent, okay? All right, since 1 and 3 are congruent, okay, now we're gonna have to prove that P and R are parallel. So the way we go about doing this is, let's think about it. If I want to prove that these two are gonna be parallel, okay, I cannot use 1 and 3 because there is no postulate or converse of that works, right? But I can use 3 and 2. 3 and 2 are alternate exterior angles to P and R. So if I can prove that this and this are the same, I'm home free, right? But since I know that these two are parallel, I know that 1 and 2 are going to be congruent, right? Since I know 1 and 2 are congruent, right? And I'm given that 1 and 3 are congruent, that means that 3 and 2 must be congruent, which means that since 2 and 3 are congruent, these two lines have to be parallel. Everybody follow that? Okay. Let's go to example number 4. Example number 4. During a race, all members of a rowing team should keep their oars parallel on each side. If angle 1 is 3x plus 13 and angle 2 is 5x minus 3 and x equal to 9, show that the lines are parallel. Okay, so the oars are parallel. So if on the picture, 1 and 2 would be what angles? Can anybody tell me what 1 and 2, what kind of angles they are? Jose.
They are corresponding angles.
Correct, they are corresponding angles. Good job. So 1 and 2, and I'm given that angle 1 is equal to what? Angle 1 is equal to 3x plus 13. And I'm given that angle 2 is equal to 5x minus 5. And I'm also given that x equal to 9. So it's x is equal to 9. If I put x equal to 9 here, what do I get? I get 27 plus 13, 40. X equal to 9 in here, I get 45 minus 5. And this is 40 also. So angle 1 and 2, which happen to be corresponding angles, are the congruent. They're the same. Therefore, these two lines have been proven to be parallel. Okay? Right, and we're done. Okay, so that's the end of 3.3.